This is just a reminder that this is our sine function and this is our cosine function. They both are one wave and their domain goes from 0 to 2 pi. That is also called the period. So the period is the time it takes to get one complete wave. So that is from 0 to 2 pi. If you remember when we did transformations, we always had a number in front of the function, and that was how much the vertical axis was stretched or shrunk. The same thing applies for sine and cosine. That a value will either shrink if it's greater, or sorry, will stretch if it's greater than 1, or shrink if it's less than 1. So for example, this cosine of x is this original one that I have in blue, and then the new one, y equals 2 cosine of x, is stretched so that the high point is at 2 and the low point is at -2. For the sine function, the original is this blue one, height is 1 to -1, and now the 0.5 sign means the height goes up to 0.5 and down to -5. If a negative is in front of the sine of x, what that does is it flips the sign over. So the curve is flipped over to the new one. So this is the new negative sine of x. And just like in transformations, if you have a number after the function, which would in this case be our b value, that is just going to shift the graph up or down based if it's positive or negative. In this case, it would shift it up 2, which means I took the original sine of x and I just moved it up 2 units. So this is sine of x plus 2. The b value in front of the x is, again, the horizontal shrink or stretch, and it works opposite. So, for example, if you have sine 2x, that means you will get 2 curves in the normal period from 0 to 2 pi. So what we do is we take 360 degrees, or 2 pi, and we divide by 2 because that's the number in front of x, which means the period is 180 degrees or pi. So what that tells us is we get one curve from 0 to pi, and then we would get a second curve from pi to 2 pi. That is called the period. Use the b value to find the period. The c value in our transformation is inside the parenthesis. It's right after the x. If you remember, that's the value that tells you if you go right or left. If it's negative, you move right. If it's positive, you move left. And then the other thing is the b value has to be a factor. So if you're given an equation where that is not a factor, what you have to do is factor that value out first. So in this example, I'm taking out the 2 from both. So 2 is the factor, and then I have 2 plus pi over 2. So my phase shift is pi over 2 to the left. So just remember to take out the factor if you haven't already done so. This slide is just a reminder of what A, B, C, and D represent. D is vertical shift, up or down. C is the right or left, that's inside with the x. You use b to find the period, so you take 2 pi and divide it by b. And then amplitude is a, or the height. Another way you can calculate amplitude is take the highest value of y, so the highest point, and then subtract the lowest y value, and then divide by 2. That's another way to find the amplitude. Now we want to put the graph and the equation together. So the graph that's shown is the graph of 3 times sine of half of x. The amplitude is a number in front of sine, so in this case that would be 3. And you can see on the graph that it's 3 high and goes low to -3. Period would be 2 pi divided by b, and in this case b is a half. So when I multiply by the reciprocal, I get 4 pi. And as you can see, it takes 4 pi to make one curve. When you look at the graph, I'm going from 0 to 4 pi to make one sine curve. So my period is 4 pi. There is no phase shift because there's no number after the x in the equation, and we're not moving it right or left. In the second one, our amplitude is 2 because of the -2 in front. And what the negative does, if you remember, it flips it over the x-axis. So the original cosine would have been flipped this way. The other thing that happens with the cosine in this case, because when I drew that red graph, it almost looks like sine, but this minus pi over 2 tells us we're moving right pi over 2 units. So what that means is, instead of starting cosine at 0, I'm really starting the cosine at pi over 2. So pi over 2 would be this point here. So if I trace that graph, it would kind of look like a girl with hair that's curling at the bottoms. And remember, that is flipped over, so it's a hill instead of a valley. So period is 2 pi, and that's because there is no number in front of the x other than a 1. Phase shift is pi over 2 to the right. On this page, we're matching some graphs with their equations. First of all, 2 sine of half x. I need my amplitude to be 2, so I can see on letter B that my height of my graph is at 2. And then my period would be 2 pi divided by that 0.5 or a half, which ends up being 4 pi. So as you can see, from 0 to 2 pi, we only have half of the curve. I would need another 2 pi to get the bottom of the curve. So the first equation is B. The second equation, we took sine, and now we're doubling the period, which really means, the 2x means, that we're taking 2 pi and we're dividing it by 2, which means the period is pi. So I should be able to get one curve from 0 to pi, which means I've got 2 curves from 0 to 2 pi. And you can see that we've got 2 sine curves here, and then because of the negative in front, it is flipped over the x-axis. So C would be the second one, which leaves A to be the third one. We've got a stretch of 3 vertically, and then plus 2 means we moved it vertically up 2, and then the period is 4 pi.